channel. In this video lecture, we'll be solving this problem max consecutive ones 3, which is a lead code medium problem. In this problem, we are given a binary array nums. So what is a binary array? It's an array of integers which contains zeros and ones only. And we are also given an integer k. What we have to do in this problem is to return the maximum number of consecutive ones in the array if we are allowed to flip at most k zeros. Fine. So we have to return the size of the window which is largest, and the window must contains ones only after we flipped at most k zeros. Fine. So that's the problem. Let's better understand the problem statement using an example. So let's take this example. We have nums array which has a size of 11, and this is a binary array. The integer k is given as 2. That means in any window that we take, we can flip at most two zeros to 1. Here flipping means converting 0 to 1. So let's see the output for this particular test case. So let's take the very first window. So in the very first window, we can see that we can flip at most two zeros to 1, we can have at most 5 consecutive ones. That means flip this 0 to 1, flip this 0 to 1. We have exhausted our capacity to flip the integers, and the maximum number of consecutive ones that we have achieved are 5. So we have 5 answer till now. Fine. Then let's see next window. So the next window will be of size 4 because we can flip only two zeros to 1. So if we flip this 0 to 1, this 0 to 1, we have exhausted our capacity k, and the window that we have obtained is of size 4, which is worse than the previous result. Hence we are not going to consider this window. Let's take next window. So since we can flip two zeros, the number of elements or the number of consecutive ones that we can achieve if we start from the third one will be 3 elements or 3 ones, and the answer for this will be 3, which is worse than the previous answer. So this is also not allowed. Let's take the next window. Here this is of size 2 only because if we start from the fourth element, we will exhaust our capacity to flip the integers right at the fifth element. We cannot move to the sixth element. Hence in this case we can achieve only 2 consecutive ones. Let's take the next window. Here we can see that in this window we can achieve 5 consecutive ones because we can flip this 0 to 1, we can flip this 0 to 1, and then we have 3 consecutive ones, which will make a total 5 consecutive ones in this window, which is not the better answer than the previous answer which we have. So let's move to the next window. Let's start from the sixth element. Here if we start from the sixth element, we can cover all the elements till the last element because we can flip this 0 to 1, we can flip this 0 to 1, which will make 6 consecutive ones in the current window. That means if we flip this 0 to 1 and this 0 to 1, then the maximum number of consecutive ones would be 6. 1, 2, 3, 4, 5, 6, and this will be updated to 6. Hence the answer is 6 for this case because this is the maximum number of consecutive ones which we can achieve in this particular test case. Fine. So how do we solve this problem? At this point you must have known that all we want in this problem is to find the largest window which contains consecutive ones. Fine. So what would be the strategy to solve this problem? Obviously we can use 2 pointers, or we say sliding window. We do in sliding window. How do we use sliding window technique? Because here in this problem all we have to do is to find the longest window which contains consecutive ones. So we keep a pointer at the very first index. Let's call it pointer first. Then we start another pointer. Let's call it pointer second, and we move our second pointer till the integer in the right direction until we have exhausted our capacity k. That means we have flipped exactly k integers to 1. So we start our second pointer right from the first index. We check the next integer which is also 1. So we do not have to use this capacity. So we move our pointer to the second integer. Now the valid window has a size of 2. The second pointer is standing at the second integer. Then we check the next integer, which is also 1. So we can safely move to the third integer without flipping the elements. So the second pointer is standing on the third integer. Now I check for the fourth integer. Here we have 0. That means we have to flip this integer. So if we flip this integer, k will become 1 and this will become 1, and the second will be moved to this point. Now the second is standing at fourth integer, and the answer or the window size, the maximum number of consecutive ones till this point is 4. Then I check for the next integer, which is also 0, so we have to flip this one as well. So I flip this as well. So this is flipped to 1, and the second pointer is moved to the fifth integer, while the answer becomes 5 at this point. So at this point I have a window of size 5. That means I have 5 consecutive ones in the given array. Then I check the next integer, which is also 0, but k is entirely exhausted. We do not have capacity to flip the integer. Hence, we cannot expand our window till fifth integer. The maximum we can go starting from the first integer is till integer number 5. So this is the maximum window which we can obtain if we start from the first integer. The answer is 5. Then depending on the sixth integer. Now this window which I currently have is not a valid window. We cannot have consecutive ones in this window because we have 3 zeros in this window. So this is the point where I have to slide my window, or I have to move my first pointer. Now I start moving my first pointer till the point I obtain a valid window. So when will I obtain the valid window? If I move my first pointer to the second position, the current window will become this one. Is this a valid window? No, because I have 3 consecutive zeros, which is not allowed because the capacity is 2. We can convert exactly 2 zeros, not 3. So I move my first pointer to third integer. Is this a valid window? No, because we again have 3 zeros in this window, while we can have only 2. So I move the pointer to the fourth integer. Is this a valid window? No, it is also not a valid window. So I move to the fifth integer. The first is standing on the fifth integer. Is this a valid window? And the answer is yes. It is a valid window. We can convert 2 zeros to 1. Fine. Then again I come to the second pointer. I will start moving my second pointer till I have a valid window, or I do not exceed this capacity k. So this is the current window that I have. I will move my second pointer to the next integer here, and the window will be this. This is also a valid one. Then I will keep moving the second integer till the second last number, and the window will be this one. Fine. So let me point out what is the current window. Okay, so this is my current window on which I am standing, and the size of this window is 5, and this is a valid one. That means I can have 5 consecutive ones if I flip these 2 zeros by using this capacity. Fine. Now I move my second integer to the next integer, which is 0. Now the second stands here. Now this window is not a valid one because I have 3 zeros in this window, 1, 2, 3, while I can have only 2 zeros. So I have to move this pointer towards right till the window is valid, or till I have exactly 2 zeros in the window. And I move this first pointer to the next integer here, and the current window is this. Now this is a valid window because I have exactly 2 zeros in this window, while the number of consecutive ones that we can achieve in this window will be 6. If I flip this 0 to 1 and this 0 to 1, then the number of ones would 4, 5, 6, which is better than the previous answer, which was 5. And hence I update the answer to 6, and I traverse my entire array. I cannot move my second pointer to the next integer, and hence this would be the answer. The maximum consecutive ones that we can have will start from integer number 6 till the last integer of the array. Fine, and the answer for this test case would be 6. So that's how we implement the strategy. That's how we solve this problem. We just use two pointers. This is called a two pointers approach or sliding window approach. All we have to do is to start two pointers, initialize two, and the challenge was to figure out the strategy to move those pointers. Fine. And in this problem, all we have to do is to keep the second pointer moving towards the right till the window is valid. For that, I need to keep track of number of zeros that I have encountered in the current window. If the number of zeros exceeds the limit, which is k, then that means the window is invalid. And in that case, I will start moving my first pointer towards the second pointer till the window becomes valid or the number of zeros decreases to k. That's all we have to do. Pretty standard problem. Let's see the implementation of this idea. So at this point I would recommend you to try to implement the idea by yourself, because that will help you to understand these problems better, because the same idea can be used to solve multiple problems with a little variation. So let's see my implementation. This is the longest ones function which takes in the nums array and the upper limit for the number of zeros k. I calculate the size of the nums array, initialize two pointers j, initialize a pointer j. This is the first pointer or the left pointer, and this is count, which will be used to count the number of zeros in the current window, and this is the answer variable which is initialized to 0. Let's iterate over the array starting from the first element till the last element. If I encounter a 0, I will increment this count variable because I'm counting the number of zeros in the current window. And the current window initially is basically the window having exactly one element, because both pointers are standing on the first element. Then this while loop is used to handle the invalid condition whenever we have an invalid window. So when do we have an invalid window? When the number of zeros in the current window exceeds the limit. In that case, I'm moving my left pointers towards right. And here whenever I encounter 0, I'm excluding that 0 from the current window. I'm decrementing my count variable by 1. Fine. After that, I'm updating my answer variable with the size of the current valid window. So pointers I and j defines a particular window. This condition is used to make sure that the current window or the boundary defined by these pointers is valid. It must not contains number of zeros exceeding k, and this condition is basically updating the maximum number of consecutive ones in the window. So this variable will filter out the longest number of consecutive ones that we can have in this particular array using exactly k flips or at max k flips. At the end I will return answer. A standard two pointers problem. Let's see the time and space complexity for this. So time complexity for the given implementation is big O of n, because we are iterating over each element exactly once. We are just traversing over the array exactly once. We are moving our window over the array exactly once in the worst case. That's why the time complexity is big O of n. While the space complexity for the given implementation is constant, because we are not using any auxiliary space to store anything. So let's jump to the implementation. So I calculate the size of the nums array, initialize the answer variable to 0, the left pointer and the number of zeros in the current window with the count variable, which is initial. Then I iterate over the array. So and here I'm counting the number of zeros in the current window, and this condition is used to make sure the current window is valid. And here I'm updating my answer variable with the size of the current window. Finally, at the end I will return my answer, which will store the maximum number of consecutive ones which we can possibly have by using at most k flip operations. So this is the implementation in C++. Let's see the implementation in other languages. This is the implementation in Java language, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to my YouTube channel for further updates. I will soon be launching different playlists for different topics of data structures and algorithms. So stay tuned with me. I will see you in the next video.